So today, review for our trig quiz. So let's get started right after that. So first of all, question number 1 is a right triangle. So I'm going to use my right triangle trig information, which is up on the board, the blue stuff, right? It's the blue. Sine, cosine, tangent, right? So first of all, you always work from your angle, okay? So you pick the angle you know, right? Choose the given side, right? And then I'm going to find either little c or little a. It doesn't really matter. I'm going to find little c first, though. It does not matter. So I'm going to go for little c. So if I do that, opposite hypotenuse, right? Opposite hypotenuse. Opposite hypotenuse is sine. So sine of theta, but sine of theta is really the angle, right? So instead of sine of theta, sine of 36. Equals, according to that, it's the opposite over the hypotenuse, which is the 10 over the c, opposite over the hypotenuse. Okay? So I set it up, and then I need to cross multiply. Well, the c comes up here. If I move the c up here and put the c right there, then I'm going to have to divide by the sine of 36. Remember that? So I'm going to say c is equal to 10 divided by the sine of 36. And I'm just going to use my calculator to get that answer. So, okay, no problem, I can do that. I'm just going to go 10 divided by the sine of 36, and I get an answer of about 17. Okay, so little c, or side c, is 17. Okay, I'm going to put that into my triangle, and I'm going to use that information. Okay, so I'll go 17 right here. Okay, now, angle A is pretty easy, right? These two angles must add up to 90, so angle A is pretty easy. So to find angle A is just going to equal 90 minus 36, and I think that's 54. So angle A is 54 degrees. Pretty easy so far. Hopefully I'm going slowly enough. If I get going too fast, please tell me. Megan, will you tell me if I get too fast? Finally, little a, I'm just going to use Pythagoras theorem, right? It's a right triangle, so I may as well use Pythagoras theorem. So I'll go a squared plus 10 squared equals 17 squared, right? A squared plus 100 equals, I think it's 289. Double check, 17 squared, 289. I've been doing math way too long to know that. Minus 100 is 189. But of course, I've got to take the square root of that, right? Because a squared is square root of 189. I don't know. 13.8. How's that? Thank you, Leora. There you go. Okay, thumbs up on that one. Can you do that one tomorrow? Thumbs up, right? Okay, let's move on to number 2. Okay, number 2 is not a right triangle. It is not. So our sine, cosine, and tangent will not work. There is no hypotenuse. So what we do is you either use the law of sines or the law of cosines, one or the other. If I have a pair of opposites, I use the law of sines. If I have a pair of opposites, I use the law of sines. So I have opposite. So I could find angle P first with opposites. Okay, so I've got angle P and the 10. So I just like to set up and write down what I don't know first. I don't know angle P. So I'm going to set it up as sine of angle P over its opposite side, which is 10, equals sine of 65 over its opposite side, which is 13. Okay, and we're just going to multiply up the 10. I'll get a decimal, and I'll do the sine inverse because I'm looking for the angle. So I will take a sine inverse. So I'm going to just simply multiply up the 10 here. I'm going to go clear all that. So we're going to go 10 times the sine of 65 divided by 13. And I should get a decimal, which I expected because I'm going to sine inverse that answer. Sine inverse that answer. So I'll just go sine inverse of my decimal at 0.697. Boom, 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 boom. And we'll round it to 44.2. Okay, if you can round to the nearest tenth, that'd be great. Round nearest tenth, so I get a 44. So angle P, I got about a 44.2 degrees. So I'm going to put that in there, 44.2 degrees. Okay, good. So far, so good. Now, angle I is pretty easy. 180 degrees in a triangle, right? So that's easy. So I'm going to go, okay, for angle I, I'm just going to go 180 minus my 65 plus my 44.3. And again, I'm just going to use my calculator to do the work. No reason to do it the hard way. 180 minus my 65 plus my 44.3. And I get an answer of about 70.7. Okay, so angle I is a 70.7 degrees. How am I doing? Thumbs up so far? Yeah, Lima? Oh, so I'm off by a little bit, aren't I? Thank you. So that's probably 77.8, isn't it? Thank you for catching my mistake. Alima, with me it's glasses on, glasses off, glasses on. I can't. I'm blind. It's terrible. Okay, then. Now, you cannot use no Pythagorean theorem. No, it's not a right triangle. So I'm going to set up my opposites, right?
Are you on number 3?
I'm still on 2.
Oh.
I'm going to set up my opposites, okay? There's my opposites, right? So we set up our opposites. We'll go little I over the sine of 70.8 has to equal 10. Whoops, not 10. Let's use 13. That's more accurate. We could have used the other, but that's more accurate. 13 over the sine of 65. Okay. I'm not finding an angle, so I will not push the sine inverse, but I will just multiply that up there, right? So I'm going to go on my calculator. Oh, you guys can see it there. Kind of see it. Slide that. There we go. There you can see it there. Kind of. A little bit of glare. So I'm just going to go 13 times the sine of 70.8 divided by the sine of 65. And you can answer about 13.54. Okay. So little I is about 13.5. Thumbs up. You guys okay with this? And you can do this tomorrow, right? Okay, good. Trig's not bad. Just have to follow formulas, right? Okay, number 3. There are no opposites. So you cannot use the law of sines, but you do have side, angle, side. So you do have side, angle, side. If you look at the board, over there on the chalkboard, it says side, angle, side in orange. It says find the opposite, and you've got your law of cosines. So little x would be my opposite, right? And these two are my adjacents. So I'm going to set it up, okay? X squared, which is opposite squared, is equal to, so just following the formula, adjacent squared, 6 squared, plus adjacent squared, 11 squared, minus 2 times my adjacent, which is 6, times my adjacent, which is 11, times the cosine of 95 degrees. And again, I'm just going to put that in my calculator and let the calculator do the work for me, right? All right, so I'm going to just go and try and type that in clear. So it's just going to go 6 squared plus 11 squared minus 2 times 6 times 11 times the cosine of 95. Okay, and I get an answer, but then I have to square root that because I get really x squared equals 168.5, but I square root that, right? Because that's x squared, so I've got to square root, right? So I'm just going to take the square root of that answer, and I get square root of that, so I get about let's say 13, yeah. So I'm going to go, little x is about 13. Okay, I'm going to label that, put my calculator, okay, put it in there. Now, at this point, we've got a couple of choices, okay? We could continue using the law of cosines, but it's so much easier. The law of sines is really easier because once you have your opposites, right? If you've got a pair of opposites, use the law of sines. The law of sines is really pretty easy, okay? So I've got my opposites, so I could find either opposite. Let's find angle z. So opposites, right? So I'm going to set up my law of sines. So I may as well go sine of z over 11 equals sine of 95 over 13. Okay? Set up my opposites. It's really pretty easy, isn't it? Cross multiply, bring the 11 up there, and again, I'm just going to use my calculator to get that answer. So we're just going to go 11 sine 95 divided by 13, and I get a decimal, right? But I need to take the sine inverse of that answer because I need that angle, right? I need the angle, so always inverse, so it's sine inverse of that answer of that decimal, and I get about 57.5 degrees. Okay, so angle z is approximately 57.5 degrees. Okay, let me put that in there, 57.5. How am I doing? Pacing's okay? Yeah, slide over. There you go. How am I doing? Pacing okay? Not too fast? We're good? Okay, and then finally, angle Y, easy squeezy, right? 180 degrees in every triangle, right? 180. So to find angle Y is going to equal the 180 minus my 95 plus my 57.5. I'm going to use my calculator to get that answer. And I'll just go 180 minus parentheses 95 plus 57.5, and I get an answer about 27.5 degrees. Okay. Thumbs up. Okay, good. Okay. All right. Number 4. Always ask yourself this question. Are there a pair of opposites? No, there aren't. If there are a pair of opposites, we use the law of cosines. If there aren't, we use the other, which is the law of cosines, okay? So I have side, 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 right? So if I look over there and I'm looking for side, 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 it's cosine again. So I'm going to find angle G, and I'm going to use the law of cosines. So all right, I'm going to say that the cosine of angle G is equal to, here's my adjacent, this is my adjacent, and that's my opposite, right? So I'll go parentheses, 11 squared plus 15 squared minus 17 squared. So I'm not done, but it says it equals adjacent squared plus adjacent squared minus opposite squared all over parentheses 2 times 11 times 15, because it says 2 times adjacent, okay? Now, I know I'm going to have to cosine inverse because I need an angle, right? So we're going to get a decimal. I'm anticipating a decimal, and I'll cosine inverse. Okay, so then in my calculator, I'm just going to go, you have to use parentheses, 11 squared plus 15 squared minus 17 squared, parentheses divided by parentheses, 2 times 11 times 15. And sure enough, I get a decimal. I figured that. Because I need the angle, so I cosine inverse that. So we'll go cosine inverse that answer, right? Second cosine inverse that answer. And I get an answer of about 80. About 80.1, 80.05 or 80.1. So that means that angle G is about 80.1 degrees. Okay, I'm going to put that in there, 80.1, okay? How's that? Now, you could do the law of cosines again. No problem, you can. I like the law of sines because I think it's easier. But if you want to use the law of cosines to get I, it will work. It just changes your adjacents and your opposites. Or if you want to find angle D in the law of cosines, it changes your adjacents and your opposite. It works. But I'm more apt to use my law of sines because if I have a pair of opposites, let's just do it, okay? So let's find angle D, but let's do angle D using the law of sines. All right, I'm going to go then sine of D over 15 equals the sine of 80.1 over 17, right? Sine of an angle over its opposite side is equal to sine of an angle over its opposite side. Then I'm going to multiply up to 15, okay? And use my calculator to do that. Okay, clear. So I'm going to go 15 times the sine of 80.1 divided by 17. And I get a decimal. I kind of expected that because I'm looking for an angle, right? So I have to sine inverse that. So I'm going to sine inverse that answer. And I'll do that right now. I'm going to go sine inverse that answer. So I get an answer of about 60.4 degrees. So angle G, or D, sorry, my bad. Angle D is about 60.4 degrees. Okay, let me put that in there. 60.4, okay? Now, we're getting there. So, the third angle, angle I is easy. In geometry, 180 degrees. Right, Connor? And I'm going to go angle I is equal to 180. You two should just sit together. Minus 80.1 plus 60.4. Okay, again, I'm just going to use my calculator. Okay. Clear, 180 minus 80.1 plus my 60.4, and I get an answer about 39.5. Now, hold on, we're not done because there's one more question. We got to take a look at this. And it's actually pretty easy, and that's the area, okay? That's the area. So to find the area, let's do the area down here. The area's not hard because, again, we look at our board. Up in the corner, on the right-hand corner, it's above the Christmas tree, it says area equals, you ready? 1/2 adjacent, so 11, times adjacent, which is 15, times the sine of the angle, or sine of 80.1. Okay, and I'm just going to let my calculator do the answer. Do it. Okay, so area's not hard. I'm going to go 1/2 times 11 times 15 times the sine of 80.1, and my answer for area is just an 81.3 centimeters squared. 81.3. Alright, how am I doing? So far so good? Okay, turn the page. Alright, now, on 5, I'm going to do 5 on a separate sheet of paper because I'm going to have to draw, there's 2 possible triangles. I'm going to try and do a really good job drawing it. So I'm going to need my protractor and my ruler, okay? So I'm going to draw a 45-degree angle first, okay? So draw that with protractor ruler. So this one problem is worth 7 points. See, we've got to know how to do this, okay? So I'm going to put point A because I need to draw an angle, right? And I'm just going to draw this line out. And I don't know how long this line is. I have no clue. I'm just going to draw it, okay? That's called the terminal side of an angle, okay? I need a 45-degree angle right about there. And then it looks like B has to be 8.5, so 8.5 centimeters, right? 8.5. 8.5 is there. Okay. That's B is 8.5, and that's 45 degrees. Okay. How am I doing? Am I going all right? So far, so good. Little a has to be 6.5. Okay, am I going too fast? No. Okay, so 6.5, and it says 2 triangles, so it should fit in 2 places. We've seen this before. So I have to make it try and fit, and 6.5 fits right about there. There's the first triangle, okay? And then I will draw the second triangle, but not right now, but the second triangle would actually be right about there, okay? Do you see it? But I'm not going to draw that one yet. Let's just solve the first triangle, okay? Okay, this is little a, which is 6.5. All right, what I want to do first is label my triangle. If this is side B, that's got to be angle B, angle A, and that's got to be angle C, okay? All right, so I have a pair of opposites, right? See my opposites, right? So the first thing I'm going to tackle then is angle B. Angle B, because I've got opposite. So let's set up sine of B over 8.5 equals the sine of 45 over 6.5, okay? I'll just multiply it up. I will have to sign inverse because I don't know the angle. So I will get a decimal. I will sign inverse it, okay? So on my calculator, we're just going to go to 8.5 times the sine of 45 divided by 6.5. Yeah, I got a decimal. Kind of expected that, right? And I'm going to sine inverse that answer, right? So a sine inverse that answer. And about 67.6. Okay, so angle B is about 67.6 degrees. Let's put it in there. Okay, how am I doing? And then angle C is pretty easy to find. Angle C. Angle C is just 180 minus the 45 plus the 67.6, right? 180 degrees in a triangle. We know how to do that. We all passed geometry. And if we didn't pass geometry, then don't tell me because you're not supposed to be in here. 180 minus parentheses 45 plus 67.6, right? And you get 67.6 again? No, 4. Okay, 67.4. I was thinking, wow. Okay. So this has got to be a 180 minus 45 minus 67.6. Yeah, 67.4. Okay. And then finally, let's find little c, which is down here. And again, opposites, right? Opposites. If you have your opposites, set up your opposites. So we're going to set up little c over the sine of 67.4 equals 6.5 over the sine of 45, cross multiply. I do not need to sine inverse. I'm not looking for an angle. I'm not going to sine inverse. I'm just going to do the math. Put my calculator to the math though. So I'm going to go 6.5 times the sine of 67.4 divided by sine of 45. And I get about 8.5. Okay, 8.5. All right, now everybody's got to pay attention. Everybody's got to be awake. This is where kids mess up, but you're not going to mess up, okay? When you draw the other triangle, check it out. When I draw the other triangle, 6.5 could be right about the measure, right? Right about there maybe, okay? Let me highlight the triangle. So the second triangle is this one. Here's our second triangle, okay? So angle B is no longer there. Angle B is there, okay? Now, here's the trick. Everybody listening? Everybody listening? Connor's listening, of course he is. Big thing. We know this is 6.5. This triangle, which we are not solving, is an isosceles triangle, 6.5, 6.5, which means this angle is equal to this angle, okay? So that means this outside angle is 67.6, but that's not the angle we're looking for. We're looking for this angle B here. It's easy. If you know this is an isosceles, you know those two angles are equal, then angle B is easy. It's just 180 minus that. That's it, you guys. There you go. Minus 180 because it's a straight line, right? Straight line. So the other triangle, to find our small, let's call it the small triangle. The other triangle, angle B is just 180 minus that angle B, right? 67.6. What'd you get, Leora? 112.4 degrees, okay? You have to recognize, to do the second triangle, you have to recognize isosceles, which means base angles are equal, so that angle is equal to that angle, but then you subtract from 180 to get that angle, okay? It's really easy, but just have to recognize the isosceles triangle, okay? So then, from here we can get angle C from 180, right, minus my 112.4, plus my 45, angle C equals, I don't know, give me a second, 180 minus 112.4 plus 45, 22.6. And then finally, little c, which is not all the way across, little c is just that little piece right there. We'll set up our opposites again, right? We'll set up our opposites, but with a 22.6 degree angle, right? So to find little c, we'll go, all right, little c over the sine of 22.6 equals 6.5 over the sine of 45. I'll multiply that up, right? And again, you're not going to inverse, no sine inverse, because you know the angle. You're not finding an angle. You're just going to go 6.5 times the sine of 22.6 divided by the sine of 45, and I get about 3.5. Okay, this is worth 7 points. You have to draw it right. You have to get angle B. You have to get 3.5 is the side, yeah. So you got to get all three missing sides here, all three missing pieces here, okay? All right, you ready? Let's finish this thing up. With a little luck, I'll get it done before the bell rings. I think I might. Be good. No, I don't even have homework for you. Isn't that nice?
Sweet.
A wheelchair ramp. We did this, okay? So a wheelchair ramp needs to be built to comply with code. If the length of the ramp is 36 inches, and the height is 5, right? This is the one that Simon did for us earlier, right? And it is a right triangle, so we can use right triangle trig. Opposite hypotenuse, right? So we're just going to set up sine of theta equals my opposite over my hypotenuse again. we're looking for the angle, right? Looking for the angle, so we really do the sine inverse of 5 over 36. I don't know. Let's find out what the calculator tells me, huh? I don't know. Let's see. What are we going to get? We're going to get sine inverse of 5 divided by 36. And I get about 8 degrees, okay? I get about 8 degrees. So theta is about 8 degrees. Easy for Granny to get up, right? Granny can get up at 8-degree angle in her little wheelchair. She can do it. Okay? 7. Identical problem to what was done in the warm-up, okay? So, and again, I'm not much of an artist, but I'll do my best. So if I try and draw, so pentagon is inside a circle, right? And I'll just try and get it the best I can. All right, just do this one? Yes, isn't that nice? We did this on the warm-up, so it should be easy. Skip it? Yeah, let's skip it. Okay, guys, remember, I'll just set it up. 72, 18, 18. Area, 1/2, 18 times 18 times sine of 72. Yeah, we just did it.
Wasn't this different than that? Because it's side lengths of 18.
Oh, yeah.
Want to find the radius. Wasn't the radius 18 before, and then you needed to find the side length?
Yeah.
That'd still be 18, 18 side lengths, right?
No, because the radius is different.
because that's not the radius this time.
Oh, this
The
is
radius
different.
18, so this
Oh, this is different. Oh, thank you. Well, you know what I'm going to do, Sarah, then? Is I'm probably going to have to make it into a right triangle. Yeah, so that's 36. That's 54, right? Oh, yeah, thanks, Sarah. That's 54. Call that H. Opposite over adjacent. Let me look at my little mini right triangle. 9H, 54 degrees. So I'll use tangent of 54 is equal to H over 9. Right? Right? Multiply by up to 9 times the tangent of 54 equals H. I don't know what that is. Thanks, Sarah. Sarah saves the day again. 9 times the tangent of 54. And I get about 12.4. Now I can find the area of the triangle, right? Which is 1/2 base times height, right? And I'll multiply that times 5, because there's 5 of those triangles, times 5, because of the 5 triangles. Let me do that in my calculator. 0.5 times 18 times 12.4 times 5, and I get about 558 centimeters squared. I think, sir, it was different. Okay. Oh, I just did the whole thing in my calculator. Okay. Last but not least, I'm going to have to do this one on a separate sheet of paper. I got 10 minutes to get this one done, okay? So it's not bad. Hey, this is the identical one we did in our notes. It is. So we don't really need to do it. This is the same. It's the exact same as our notes. Exact same one, okay? Now, on the bearing to get back, that's the extra, okay? All right, and I will stop it there.